Welcome back to our YouTube channel. Today we want to continue from the aspect of qualitative analysis, actually the aspect of alternative to chemistry practical, how to answer questions correctly on alternative to chemistry practical. We have done the first part of this section where we give you clues and tricks on how to answer questions on testing for cation present in a chemical sample. Today we want to look at how you can know how to answer questions on testing for cation present in a chemical sample. That is what we want to do for today, and I would like you to follow me through the class where I will simplify to you, where I will show you tricks and method on how to detect cation present in a chemical sample and how to answer questions correctly in your examination hall. Let's go to class. Today, let's look at how to test for common anions. How to test for common anions. And common anions they will ask you to test in your examination hall is Cl minus, NO3 minus, CO3 2 minus, and you have to test for SO4 2 minus, SO3 2 minus, and S2 minus. These are common anions that they actually have students to detect or to find inside examination hall. So first thing, let's look at how to test for Cl minus. Now know that when we did for anions in our previous video where we did for anions, the two common reagents that we used to test for cation, when we did for cation, the two common ions that the two common reagents that we used to test for cations are sodium hydroxide solution and ammonia solution. But other anions, we don't have a specific reagent that we used to test for. So we don't have common reagent that we used to test for the anions. They have their peculiar reagents. So once you see the test, you can know the likely ions that you want to test for. Anytime you want to test for chloride ion, you ask you to add silver nitrate and nitric acid and ammonia solution. Now, anytime you see in your test side, they are adding silver ion, silver nitrate and nitric acid and ammonia solution under your test side. What you want to test for is chloride ion. Note, under your test, you are adding silver nitrate with nitric acid with ammonia solution under your test side. That's what they are asking you to add to your test sample. What you want to test for is chloride ion. And the peculiar color for chloride ion is white precipitate. When you add this nitric acid to it, it will still remain insoluble. Your white precipitate is still the same color. Precipitate remain insoluble. It still be white precipitate that you are going to have here, which I say precipitate insoluble. But when you add ammonia solution to your test sample, what will happen is that the precipitate will now dissolve to give a colorless solution. So that means that when you add ammonia solution, which is your confirmatory reagent test, what you're going to see is that your white precipitate will dissolve and it will now change to a colorless solution. What you see there is confirmation of Cl minus. So what you are going to have is Cl minus is confirmed. But these first two, Cl minus is present. But here you write Cl minus is confirmed. That's how to test for Cl minus. Alright, let's see. If you want to test for your NO3 minus, you want to test for it. These are the peculiar reagents that you are going to add. They will ask you to add your test sample. You have to add iron sulfate and your sulfuric acid to your test sample. What you want to test for is NO3. Note that anytime they ask you to add freshly prepared, FeSO4 and sulfuric acid to your test sample, what you want to test for is NO3 minus. And your observation is a brown ring will be formed at the junction of two layers. That's what you are going to write as your observation. Note, when you are adding these two reagents to your sample, it's NO3 minus that you want to test for. That is the trick, and this will be your observation. That will be your observation. Let's go to the next anion that I want to test for. Let's move to how to test for CO32 minus, SO32 minus, SO42 minus, S minus. Now, anytime you want to, they want to test for any of these ions, they will ask you to add barium chloride to your test sample. Note, anytime you are adding barium chloride to your test sample, the likely ion that you want to test for is CO32 minus, SO32 minus, SO42 minus, or S2 minus. So what you are going to be looking at is your test. What are they asking you to add to your test sample? So if you are adding barium chloride to your test sample, these are the likely ions they want you to what? To test for. And for these four ions, they will behave the same way in barium chloride. They will give you white precipitate as their color. But when you want to begin to differentiate between these four anions that behave the same way in barium chloride, they will ask you to add HCl. When you now add HCl to this sample that you have added barium chloride to, and they are giving you white precipitate, you now add HCl to the sample, and your white precipitate still remain insoluble. That is confirmation for SO42 minus, because these three, SO32 minus, SO42 minus, and S2 minus, we never give you a white precipitate again when you add HCl. But the only anion that will give you white precipitate that will still remain insoluble when you have added HCl to this sample that you have added barium chloride to is SO42 minus only. That is how to single out SO42 minus from this inference you have gotten when you added barium chloride, because all these four anions will behave the same way when you add barium chloride to it. But when you begin to add is HCl that we want to use to differentiate between these four anions. So when you add HCl and the white precipitate remains insoluble is SO42 minus that is present there. So SO42 minus is confirmed. How do you confirm for SO32 minus? When you add HCl to this test sample that we have added barium chloride to, and the precipitate now dissolve, and when it dissolve, a colorless and odorless gas was evolved, which turned blue dispersible red and turned lime water making. We know it is only CO2 gas that is to turn lime water making, and this CO2 gas can only come from CO32 minus or HCO3 minus. I'm supposed to add that to it. Let me write it. It should be from CO32 minus or HCO3 minus is confirmed. Alright, so our confirmation for CO32 minus or HCO3 minus is when we add HCl to this test sample and we see this observation. This observation is saying that CO2 gas is coming out from that test sample, and CO2 gas can only come from CO32 minus or HCO3 minus. This is how to test for HCO3 minus or CO3 minus in our test sample. Let's come to how to test for SO3 2 minus ion. Now it's still the same thing. We are adding HCl to this test sample that we have added barium chloride to. If I add HCl to it and the precipitate still dissolve to give us a colorless but irritating smell, a colorless and irritating smell gas. Irritating smell gas. Now the gas that evolved out is colorless and is an irritating smell gas. That is SO2 gas, because that is the characteristics of SO2 gas. another thing is that because it's an acidic gas, the term blue litmus paper was red. And another confirmation that we can use to it is that if it's SO2 gas, if you bring acidified K2Cl2O7 close to that gas that is coming out, if it's SO2, it will change that K2Cl2O7 paper from orange to green. Now it is orange. This acidified K2Cl2O7 paper is orange, but to change the color from orange to green, it's SO2 that can do that. They can change the color of K2Cl2, acidified K2Cl2O7 from orange to green. Or we can also use this reagent also to test for SO2. If you bring KMnO4 solution, if you bring that KMnO4 solution near SO2 gas that is coming out, it will decolorize this KMnO4. It will decolorize the solution, the sample. And we know that SO2 gas can only come from SO32 minus. So the way we test for, we confirm from SO32 minus is to look out for this gas that is coming out from it. So the way we test for SO32 minus is what? Is to add HCl to this 10 sample, and if it is our observation that CO2 gas is coming out, it can only come out from SO32 minus. So that's how we test for SO32 minus in a chemical sample, and this will be our observation. Now the last thing I want to do here is also that if you have your test sample, let's say you have your test sample again plus HCl directly also, and here is another way to test for SO32 minus. Under our acid, our property of acid, one of the chemical properties of acid is a reaction of acid with carbonate, and what will be liberated? CO2 gas will be liberated. So another way to test for CO32 minus is to add HCl directly to our test sample, and if your observation is that you have your colorless and alright, so our observation will be colorless and odorless gas. Odorless gas is evolved which turn blue litmus paper red and lime water milky. Now our inference will be CO2 gas from CO32 minus is present. That is another way. This is another way to test for CO32 minus. It is to add HCl to our sample directly. Knowing that our reaction, our chemical reaction, our chemical properties of that acid is anytime we add acid directly to a carbonate, CO2 gas will be liberated. So if CO2 gas is being liberated, it means that acid has been added to a carbonate, and that's why CO2 gas is being liberated. So here also, if CO32 minus is inside a sample and we now add HCl to it, CO2 will be liberated, and the CO2 that is liberated is telling us that CO32 minus is in that test sample. So this is another way to test for CO32 minus. Apart from when you add barium chloride to that sample, you now add HCl to it. Do you understand? Where the precipitate will dissolve and the gas will evolve an odorless and colorless gas, which turn elemental with T and turn blue litmus paper red. This is another way to test for CO2 minus. Without adding that barium chloride to that test sample, just add HCl to that sample. And if you add HCl to that sample and this CO32 minus is present, what will be this will be your observation, because this observation is peculiar to CO2 gas, because CO2 gas will be liberated from CO32 minus. When CO32 minus is inside that test sample, when you add acid to it, CO2 gas will be liberated. So that is another way to test for CO32 minus. It's either you add CO2 gas test sample directly, and if this CO32 minus is in that test sample, CO2 gas will be evolved, and this is the observation of CO2 gas. And our peculiar chemical reagent that we use to test for CO2 gas, if it's present in a chemical sample, is that CO2 gas used to turn lime water milky. When it allows CO2 gas to pass through lime water, it will turn lime water milky. That is another way to test for CO2 minus. These are common hand that usually test for during our experiment, and they will actually ask from you in your examination. So if you can master this trick that I have taught you in this class, it will be easy for you to solve question on alternative to chemistry practical when you are doing such examination. And this will bring us to the end of this class. I believe that you, by going through what I've taught you over and over again, by watching this video, you'll be able to master how to answer questions correctly on alternative to chemistry practical, even though you are not doing the real practical. This is a method of how to go about it. If this video has blessed you, do not forget to subscribe, like, comment, share with your friend to also gain from this content, and be expecting another amazing content that will be releasing on this YouTube channel. Thank you for your time. This will bring us to the end of this class today. Thank you.